You're driving your rental car, following the GPS directions to your beachfront accommodation. You're ready to have a good time with your friends when suddenly your GPS is playing tricks on you again. Would you continue to use an app that keeps crashing? The main reason why apps crash, according to Zytec.com, is that the dependencies were not sufficiently tested at development time, and overall inadequate testing, leaving the door open for bugs and errors that will affect later the app's stability. And the stability of the app equals the stability of the relationship between the user and the company. At least that's what research says. For you and your data science career, making testing a habit will have at least 4 major benefits. First of all, will boost your confidence in the code you write. It will empower you because you won't be afraid to make changes to the code. It will train your mind into thinking what could go wrong and address those situations. In any job interview, it will be considered an advantage because it will make you stand out from the crowd of data scientists who do not perform unit testing, as this is not a habit among data scientists just yet. But as companies start to see the benefits of integrating some machine learning or AI component into their applications, it is expected that data scientists do their part and bug-proof their code. For production-ready code, reliability and accountability for different scenarios is a must. While during the first stages of a data science project, testing is cumbersome, once you have an idea of which parts of the code are going to be deployed into production, making sure that the code is performing as expected is a requirement. It is generally agreed that a test coverage between 60 and 90% is sufficient for ensuring an app's stability. So if you really want to step up your game, you must start writing unit tests. Python provides really nice libraries that can help you achieve that, like UnitTest or PyTest. If you are wondering which would be some data science situations when unit tests come in handy, these are some examples. Data loading from local or external sources. Anything that has to do with data manipulation, like formatting or cleaning. When you are splitting your dataset into train, validation, and test in order to exclude data leakage. When you are performing operations with data like matrix multiplications or data transformations. When implementing some custom loss functions, or at prediction time, and when formatting the output. If you are a data scientist who has never written a Python test before, trust me, you've grasped concepts more complex than this, so do not fear. A test is meant to look at the result of a particular behavior and make sure that it aligns with what we would expect. And because we love structure, we can think about it as a 3-steps process. Arrange, act, and assert. In the arrange phase is where we prepare the function for testing. We provide the context, which is the input that will go into our function, and which is the expected result. In the act phase is where we are going to call the function, giving it as input what we've established in the context. During the assert, we are just making sure that the output of the function aligns with what we were expecting. Here are some things to keep in mind during testing. What is being tested is the functionality of a function. Tests must run fast, and tests should be storage efficient, so they should not carry big loads with them. For example, a large data file. Therefore, the data must be kept to a minimal, and we should avoid code repetition. The PyTest library has some really nice features that we can make use of in order to achieve these goals. These are fixtures, parameterization, and mockers. Let's understand each of them with some code examples. I'm working with the class author, which has 2 arguments, the first name and the last name of the author. I defined some methods that I want to work with. get the full name of the author, clean the name, clean the string, or search author in database. You can think of fixtures as your test variables that you define globally instead of redefining them each time you test a function. You define them once and then you use it across an entire test suite by just referencing them by their name. In order to create a PyTest fixture, we just need to import the PyTest package. We have to also import our class that we are working with. We are using the decorator PyTest fixture, and we are just defining our fixture author to return an object of type author, where we specify the values for each of the parameters: first name Maria, last name Strauss. When testing the function getFullName, we must specify the name of this function such that it starts with test, and then the name of the function that we are testing. In this case, getFullName, which is the function in our author class. Based on the 3 A's, we start to build the function: arrange, act, and assert. In arrange, we define what should be the expected output. Here, when getFullName of first name and last name of Maria Strauss, we are expecting the 2 strings, like the 2 parameters, to be concatenated. Because the fixture is input in the function as a parameter, we are able to call the methods that come with the object of type author. So it is possible to call the method getFullName, and the input is just going to be exactly what the fixture specifies as an input. And in the assert phase, we are just going to check whether the output of the function is going to be the same as the string that we are expecting it to output. And this is a first test that you can write by using fixtures. Now, as I said, the benefit of using fixtures is that we can use them across multiple tests without having to redefine the input every single time. In this second function, we are going to test the cleanString method. The cleanString method is just going to apply a lowercase to the input string, and it is going to strip the trailing and heading spaces, as well as any additional spaces that are in the string. So here we want to clean a string, and this is going to be the first name of the author. When applying the cleanString method on this input, we are expecting the first name to be lowercase and all trailing and leading spaces or any additional spaces in between be removed. So our expected response is Maria, and in the assert step we are just checking that what we are expecting is the same as the result of our function. And here, as you can see, the input is still the same fixture, author. Parametrization is something we do to avoid code repetitions. When we want to test a function with multiple test cases, instead of repeating the test for each of the case, we can pass the test cases as parameters into our test function. We are making use of the parametrization by using the decorator PyTest mark parameterize, and then defining the test cases as a list of tuples, where the first element of the tuple is going to be the test input, and the second element of the tuple is going to be the expected result. The input to our test clean string function is going to be the author fixture that we've defined earlier, but this is done only in order to be able to call the methods that we want to use, like here the cleanString method, and then the other parameters are going to be exactly what we've parameterized. and that is the test input and the expected value. In the assert step, we are just comparing the result of the output with the expected value that we provided in the context. So how do you test your code when it depends on other pieces of code which take a long time to run, or on external services like database connections or REST APIs? Running time-expensive operations in the test function or calling the REST API or connect to the database for every unit test is not a good idea, as it can be slow, unreliable, and expensive. The answer lies in mocking. We are going to take the case when one of our functions depends on another piece of code which is expensive to run. Our primary function here is to add a new author to a database. If the author already exists in the database, it's just going to print a message, or otherwise is going to get the full name of the author and then clean the string and append it to the database. The search author in database is going to be the secondary function that is going to take a lot of time to execute. So how are we going to mock the result of this function such that it does not negatively impact running the test for add new author? The test add new author function is going to take two inputs. On one side we have the author fixture, and then on the other side we have the mocker parameter. In the arrange step, we are just setting up our expectations. We are defining an empty list to which we should append the author if it does not exist in the database. And then here comes the function that actually is very expensive, search author in database. So instead of running this function, we are just going to mock its output to what we would expect the function to return. So the mock object is going to have the value false, which is what we are forcing this function to return. So if the mock object takes the value false, then what we are going to expect from the add new author is that it will add a new author to an empty list. We are going to assert that the length of the empty list equals what we are expecting. That is, the empty list will now have one element because the author was appended to it. We can also assert the content of the empty list according to our expectations. And what we must additionally do is check how many times the mock function was being called, which is one time. We must remember that the purpose of software testing is not to prove that there are no bugs in our code, but to find them. I hope now you are ready to start testing some of the simple functions that you use daily. I promise it's worth the effort. If you've found this information insightful in any way, don't forget to subscribe to the channel for more data science related content. And keep in mind, practice makes better.